Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today the same problem, but we're looking from the viewpoint of defender. And defender is located here on the wall, and attacker is located here, defender is here. And defender, let's assume, is shooting the same absolutely the same arrow with the same speed and using the same archery devices, and so using the same bow, and so the initial speed here at 45 degrees is exactly the same like this, right? Because I want to compare apple to apples. So it's V0 and the angle is the same alpha. And so let's see what happens here. And I can put my axis here, but I will not draw it because I will right away say that this would be the same parabola, right? And it will reach, because I can write these formulas again, but what's the point? So it will go like this, and it will land here. And so this would be another L, and this would be the same altitude, which is h, and so it will go up another h, another height, and it will be parabola directed this way, and if this is the same v0 and the same alpha, 45 degrees, it will go, this distance will be double L, and the arrow, it will be still in the air. So what will happen is that defender shooting with the same speed from the height 100 will cover this distance 400 meters. So here are attackers, they just running this 200 meters, and this is already covered by defenders, by the archers that's throwing arrows with using their bows, standing here, and those are invincible because those guys cannot shoot and cannot reach them. They have to cover this distance 200 meters, dead zone for the attackers. But not even that, because the arrow will continue and it will fall like that. Obviously, the defender can shoot at a lower angle and it will come here, so all this area is covered by defenders. But this is kind of extreme situation when they're shooting in 45 degrees and then they're reaching this distance. And there would be another part. And I don't know how we will write it. Maybe we will write it like L, right? And why it will be, because when it comes here, it will come with the same angle. So this would be the same angle alpha, and this would be alpha. And it will be continuing flying. And so if we put x, y here and x here, and here we will write x equal v0 sine alpha, and let's find the time 1 from here to here, so it would be t1, or let's use different letter, so because t and t1 are so close, let's use tau. So tau is the time that goes from here to here, so this is tau. So v0, I'm going x, so this would be v0 cosine alpha. And vertically, I will start with 0, and my speed would be directed down v0 sine alpha, tau, and then it would be another minus g tau squared over 2. And of course I can say now that x is L and y is minus h. And this described is this point. So when tau is 0, I'm here, and x and y are zeros. When time is tau, then I'm here, and I have positive L because I directed it this way. And I have minus h because my 0 here on this axis. So this point is minus h. And so I have this expression, and basically I have to work with it. And so I also can say that final speed in this direction, v final, along y-axis, it would be v0 sine alpha plus gt, g tau. Alright, and so let's continue with this. So we want to find how we will solve this. As always, vertical movement defines the tau, defines the time and height. Height we will know here, because this is the height, and this is this formula that applicable to this part, and this will be applicable to this part, and this is the sinus sine alpha. So h is known, but tau is not known. And so h is known, tau is not known. So basically this probably would be the best way of finding we move everything. Let's move everything to one side of the equation. So let's make this, see, tau is squared, so let's move it to the positive side, and let's say g tau squared, right, over 2, and this also would be v0 sine alpha multiplied by tau, and minus h, and this would be 0. And so basically what that is, this is a quadratic equation, because what is not known here, oops, sorry about that. So this is L, and in this equation tau is our not known thing, because we can of course put h from there. And so let's do that, and let's multiply by 2, so we will have no denominators. G tau squared plus 2v0 sine alpha multiplied by tau minus 2h. And instead of h I will write this. I will write v0 squared, because those things we know already. Sine squared alpha divided over 2g. 2 is gone, and it is equal 0. And so let's multiply by g again. We'll have g squared tau squared, right, plus 2v0 multiplied by g, right? Because I'm multiplying by g, everything by g. So g will disappear here, but g will add it here. G squared plus 2v0g sine alpha multiplied by tau, right? And minus v0 squared sine squared alpha equals 0. And this is my quadratic equation, right? This is my quadratic equation that I will be solving now. So I don't need anything of this. I need this to compare to my previous results, but nothing of that would be needed. And still, this is a quadratic equation that will define t, and of course only positive number will define it. And I can solve this quadratic equation in many ways. I can say a tau squared plus b tau plus c equals 0, and I can say a equal g squared, right? And I can say b equal 2v0 g sine alpha, right? Everything that in front of my unknown, and I can c equals this guy, minus v0 squared sine squared alpha. And this is a great way of solving it, and I can suggest you do it. And all you have to do is do the formula T1 2 equals 2a minus b plus minus discriminant, which is b squared minus 4ac. You will plug those numbers and you will get some result. And if you want, I can do it later. But being a lazy guy, I can already see here that I have full square or almost full square, because I have this a squared, and then I have g tau here, so this is 2, so this is b. So look what I do. I say g squared tau squared as this, plus 2, and then I put g tau in front. So I have 2a, and then I type the rest. So I have v0 sine alpha, right? And this is, I have a squared plus 2ab. So I have to put plus b squared, and b squared would be this. So I put v squared sine squared alpha, and I have to subtract it, right? Because I put b squared and I subtract the same v0 squared sine squared alpha. And all I did those numbers. But then I have this standing on its own, so I put minus v0 squared sine squared alpha equals 0, and I'm very happy because I have this, and this becomes g tau plus v0 sine alpha. And this is squared. This is those three guys. And those two are the same, so it would be minus 2v0 squared sine squared alpha. So I'm solving this quadratic equation using factorization. Not factorization, completing to the full square. So I complete to the full square by adding and deducting. And so it turns out that this minus and this minus is 2, and I'm very happy. So I have g tau plus v0 sine alpha squared equals, and this 2 goes to another side and changes sign, so it becomes this. And so I just now extract square root, and I have g tau plus v0 sine alpha, and I have here v0 square root of 2 multiply v0 sine alpha. And of course I have to put plus or minus, so this would be plus or minus. But I'm looking for the positive sign, so let me remove this, for instance, because I will not be doing AB, this formula. You can do it and you can receive the same result, but I will not be doing here. So I can isolate g tau I am isolating and moving this here, so it will become, and let me straight away have positive sign because I'm not dealing with two negatives, minus v0 sine alpha. Because when I move this, it becomes minus, so this minus and minus would be negative, but this would be positive. So I have g tau equal v0 sine alpha square root of 2 minus 1. Isn't that great? And I have tau equal v0 sine alpha divided over g, and this would be square root 2 minus 1. So I receive time, right? And this is my tau. This is the tau that needed to fly from here to here, right? And recall that if I know this time, I know the extra distance L. Because when we're flying from here to here, our L, our horizontal distance, is equal our speed in this direction, which is v0 cosine alpha, right? Multiplied by this tau. So this L becomes v0 squared sine alpha cosine alpha, right? Divided over g and multiplied square root of 2 minus 1, which is a number. Square root of 2 is 1, 4 minus 1, 0.4. So, but I look here, and I see that this is L. This is this distance L, and this is this distance L, but L. So I can say that L equals square root of 2 minus 1 multiplied by L. So, that's a great result. So that means that I am a defender standing here and shooting here. I will cover the distance 2L plus square root of 2 minus 1L. Square root of 2 is 1.4 minus 1, it would be 0.4. So I will cover the distance 2L plus 0.4L. 2 apples plus 0.4 apples, I will cover the distance 2,4L. So, if I'm a defender, I'm covering this distance. So, if I compare those distances, my distance would be 2.5 times bigger than the attacker. So the guy with the bow comes here and he will barely hit the wall. At the same token, the guy standing here will reach as far as 2.5 this distance. And the arrow will be coming straight from the top, like more than 45 degrees on the attacker. So this distance will become very uncomfortable area for the attacker, and that's the reason why they use for defense purposes the hills. They build high walls, they put a castle on the hill. This way they can protect themselves very well. And that's all about those projectiles like arrows and bows and arrows and archery, and how it relates to medieval fights. Hope you liked it. Hope you will subscribe. If you have a comment, please put it in. Thank you.